Mr. Kent Lidströms, CTO from Smartoptics, and Keith Chan, consultant from Go SDX. Kent is joining us from Stockholm, Sweden, bright and early, should be about 7-8 a.m. now, while Keith is here in Singapore. They will be sharing with us the topic, Introduction of Pluggable 400G Coherent Optics and what it means for you. With the competition between traditional 400G coherent and 400G ZR/ZR Plus coherent pluggable, will system vendors put up barriers to adoption? Will there be game changes? Over to you, gentlemen.
Thanks for the introduction. Good day, everyone. It's great to be here online with you all today. I'll be presenting the DWDM primer for IP professionals, while Ken will dive into the 400G coherent technologies update today. I have limited time, so I'll keep my DWDM primer short and precise as much as I can. What is WDM here? It is a transmission technology that multiplexes multiple optical signals on a single fiber by using different wavelengths of laser to carry different signals. I show 4 channels here only to simplify the diagram, but of course it can support, for example, 40, 80, 96 channels. For optical spectrum, we are using mainly C-band for WDM transmission, but sometimes L-band can be used as well. So the next slide here, I show the building blocks of DWDM system. It consists of edge-up filter, or we call it optical mux and demux. The picture shows a mux at the transmitting side and a demux at the receiving side. So a mux combines all inputs into a single signal, while a demux processes input signal by sorting it out into original signal individually, so it can be recognized. The second one is amplifiers like erbium tube or the long-haul Raman amplifiers to amplify the optical signals in order to compensate the signal loss. The third one is a transponder with 9N current size. The function of a transponder is to convert incoming gray optical signal that you are familiar with from the client side of the routers into predefined optical wavelength and vice versa. The last one is dispersion compensation. Here it's all about physics. Dispersive broadening of modulated signal can occur in high bitrate transmission. Without dispersion compensation, each signal symbol would be broadened so much that it will overlap with the neighbored symbols. Therefore, it is essential to compensate the dispersion before detecting the signal, so you receive a clean-cut signal. There are many challenges, for optical transmissions, and I will name 2 here. The first one, number 1, is fiber attenuation. The optical signal strength decay as it propagates through the filter of the fiber from side A to side B. The signal can be amplified with an EDFA amplifier, but unfortunately, it also amplifies the noise, as you can see from here. This caused another challenge with what we so-called optical signal to noise ratio, OSNR. And the number 2 issue here is what we call chromatic dispersion. So wavelengths arrive at different times, causing the signal to spread as mentioned before. The signal can be compensated, for example, by using dispersion compensation device. So now you have some basic idea of the building blocks, right? So I'll show you, how DWDM can help the data center to connect with each other by over short or long distance fibers. So with DWDM, you can build point-to-point, ring, or mesh topologies. to serve the needs of data center interconnect. It could be n times 100 gig, and it could be n times 400 gig, or even I would say n times 800 gig. Right? You can Google the terms when you have time, especially for the new open pluggable optics. For example, 400 gig open ZR plus and open XR optics. You don't need any transponder or muxponder anymore, as the pluggable coherent optics will enable routers or switches that you're familiar with to transmit or receive DWDM or color signals instead of just gray signals. So I hope this section is educational enough. With that, I will hand over the 400 gig presentation to Kent, and enjoy your 400 gig pluggable journey. And thank you very much. Over to you, Ken.
Thank you, Keith. Do you change slides for me, Keith, or? So what I will do, I will do an introduction to the different pluggable open 400 gig units that are available on the market today. There are a lot of discussions and buzz around this. So what I will go through here is how those are typically used, and some of the, of course, the product availability and some of the challenges that we've seen when we've done the measurement and qualifications. But if we start with a traditional way of building networks, like most of the operators build their network today, is that they have a transport network that could be either for point-to-point or more complex topologies like ROADM-based rings or mesh networks. In most cases today, they are using transponders from typically the same vendor. The transponder in this case will then be used where you have gray optics in your routers, standard SR or LR optics, and then you run it to a transponder where you do a wavelength conversion and you also add some framing on top of it, typically like an OTN framing. So on the top part there of the transponder piece, you have a 1-to-1 ratio. Each 400 gig client is translated into a DWDM 400 gig, and you can run that over your line system. On the bottom part, that shows a muxponder. There you have multiple lower rate signals, in this case now showing 2 times 100 gig, multiplexed into a 400 gig signal. Those are the traditional way of building networks. They do add some advantages. For example, especially on the top one there, you have the capability of using more advanced line side optics, so you can have higher transmit power. In this case, I've indicated as a CFP2, where I have a transmit power of 0 dBm. So you can run that into an existing network if the network is designed to handle the bandwidth and all the other criteria for 400 gig. And you also get a clear demarcation point. So for organizations, larger operators that have one team for layer 1 and layer 0 or optical transport, and one team for routers, they typically have done this, say, building concept because it's the way that they are organized. And in one of the advantages that also been traditionally considered an advantage here is that if you buy the transponders and the networking gear for your transport network from the same vendor, you can use their management system to get an end-to-end management capability. So this is still valid for the new pluggable 100 gig optics. I'll come back to that later. So this is still a valid way of using it. And if we jump to the next slide, then you see that this is kind of what the data center guys started to introduce when they started to build networks. They wanted to get rid of complexity of some of the networking gear. And they wanted to run the optics, the DWDM optics, what we call embedded into the routers and switches, to get rid of that entire transponder layer. And then they can run those directly over a transport network, both for point-to-point topologies and also for more advanced topologies. If we look at the benefits here, I mean, it's clear that it provides a lower cost because you can use a lower cost optics. And also you don't have to put the transponders in place. It also provides a network with lower power consumption, smaller footprint, and lower latency. So there are a lot of advantages of running this. We typically promote this way of running your network and only use a transponder or muxponder when they do add value. For example, if you want to go longer distances, or if you want to multiplex lower rate signals into a higher rate line signal. So what I will cover here is both of those say ways of operating your networks. So if we look at the industry standards or initiatives around open pluggable coherent 400 gig, we have the first one called OIF 400ZR. That was the first one driven by the data center guys. It's designed for point-to-point application primarily, with an optical reach between 80 to 120 kilometer or more, and if you run it in passive networks, 11 dB. It has a line capacity of 400 gig, and it only supports 400 gig client signals. So it will only be used in switches and routers for 400 gig with 400 gig Ethernet signals. It uses a CFEC on the line side, and the modulation on the line is 16.1. Another initiative that's been kind of developed as a result of requirements from operators is the OpenZR+. That is it's not a standard yet. It's in the multi-source agreement, but it's designed to handle longer distances, more for metro and regional networks. It can be adapted to use different line rates. So you can use 100 gig, 200 gig, 300 gig, or 400 gig on the line side. And when you go down in line rate, you get a better transmission performance, so you can go longer distances. And then you can also support different client formats, both 100 gigabit Ethernet, 200 gigabit Ethernet, and 400 gigabit Ethernet. It uses an OFEC on the line side and has different modulation format depending on line rate. So it uses QPSK on 100 gig and 200 gig, 8 QAM on 300 gig, and 16 QAM on 400 gig. And last but not least, you have the open ROADM specification as well. That one is very similar to the OpenZR+, with the exception that it also supports OTN clients. So if you, and then if we look at the form factors, we have 3 different form factors that are part of those standards. It's the QSFP-DD, the OSFP, and the CFP2s. They can be used in different combinations, but typically they are used so that the first 2, you see that the first 2 are typically associated with the first 2 form factors, the DD and the OSFP. OSFP is something that pretty much Arista are the only ones that have standardized on. The majority of the other switch and router vendors have gone with the QSFP-DD. And the open ROADM part is heavily associated with a CFP2 that will be used primarily with transponders and muxponders from the transport vendors. The reason why the open ROADM specification have standardized on the CFP2 is because it the bigger form factor, and also it allows for higher say power consumption. So you can use a built-in micro EDFA in that form factor to get a longer transmission distance. The other 2 versions there, they are designed to be lower cost and also with lower power consumption. So they are having a lower transmit power, typically down to -10 dBm. So you need to have line system built to handle those power levels, and those kind of systems exist. I mean, our line systems are capable of handling those, so that's not a problem, but it can be slightly problematic for if you have already an existing network to run those lower transmit power formats over those existing line systems. There will be, of course, variants of this. For example, we know that in a year from now, there will be open ROADM compliant QSFP-DD optics. So they are going to be available as well going forward. But right now, this is pretty much what it looks like. The optics themselves, if we jump to the next slide, they are very complicated. So if we try to very, very quickly on a high level follow what those are doing, they in the small form factor here, they have 8 electrical lines coming in on the back of the transceiver. Each lane uses 25 gigabaud or 50 gigabit. So that's how they form the 400 gig. Then they translated into a higher bit rates, and we are adding forward error correction and so on onto them through a DSP. Then they go through an silicon-based optical subassembly with a coherent driver and a silicon photonic modulator. Go out on a line signal with a 16 QAM modulation onto the line side. So this is actually, I mean, it's a very, very complicated module, and it's amazing that that the industry can manage to put all of this into this small form factor. If someone would have told me 15 years ago that this was going to be possible, I would have said absolutely not possible. So it's really, really impressive. The beauty of the standard here, if you jump, go to then this is now covered by the standard around how this is going to be implemented. It's covered by the Common Management Interface specification, and especially on the OEF-based 400ZR, it's very, very a detailed specification. It specifies how the optical interoperability should be done, specify how the electrical interoperability should be done, and also the entire register map is also specified in this CMIS specification. So that means if a router or switch supplier have implemented support for an OIF-based 400ZR, you are supposed to be able to run any vendor's pluggable optics into that port, very much like you've been able to do on 10 gig to get, I mean, the flexibility of selecting the supplier of optics. So this is a very new trend that I think will open up the 400 gig space significantly, and it will also change the way that people are building their, especially point-to-point data center interconnect. But I also see that many people will use this over kind of ROADM-based networks and more advanced networks as well because of the benefit that it adds. So are those now available? If we jump to the next slide, then we have the OIF-based 400ZR transceivers available. We are shipping those right now here. When I did this slide, we had shipped it to one customer in Europe. Now we've actually shipped it to 3 customers in Europe and 1 customer in Asia. We will have, we've recently also released the OpenZR Plus transceivers. So we've shipped that to a couple of customers already now. The table there that you see in the middle, the application mode, that specifies how the module, what the module is capable of doing. The intention by this is that the module itself present what kind of capability it has. When you plug these optics into a route and switch, that route and switch will read those application mode and see what kind of capabilities it has. The OIF-based transceivers only support 2 different application modes, the application mode 1 and 2. The only thing that is different between those, as you can see on the specification here, is the optical reach. The first one there has an optical reach of 80 kilometers. That means it is actually, supposed to use over amplified systems. And application mode 2 has a 25 kilometer optical reach, meaning that it's supposed to be used unamplified over passive muxes. And then if we then look at what that means, well, if now the router reads out that those 2 application modes are available, then from the user interface, the user should specify in what kind of condition will I use this. For example, I will use it over amplified networks. Then he configure the router that way, and the router will set up the optics to be used in application mode 1. Then in this case now, for example, it will get a receiver sensitivity that is -12 dBm. If you then would change it to an application mode 2, the receiver sensitivity will actually be -20 dBm. So basically you get a better receiver sensitivity in application mode 2 because it's non-amplified, so you don't get any noise into the receiver, so then it can tolerate a lower input power level. So this is what it looks like and how it worked for the OEF-based 400ZR transceiver. The OpenZR Plus transceivers that we have today, they do have 11 different application mode. For example, they have one application mode for 3 times 100 gig into a 300 gig line rate, and so on. And then they will all come with a different set of specifications, both on the transmit power and receive power. So that means you have to be aware of the fact that those are adaptive. So depending on how you use them, they will actually have different specifications. So that's something that you should be aware of. And I do get some frequent questions, if we jump to the next slide, around how those are working in the systems today. Well, if we look at the router and switch side, pretty much all of the suppliers or vendors there, they have 400 gig capable switches ready today. And typically they work with gray 400 gig optics, but very few have added support for the 400 ZR optics at this point. But we expect pretty much all of them to include support for this during 2021. So we start to see more and more beta softwares and also more supported software for the 400 ZR optics. So that's of course a kind of a necessity in order to get this to work properly and really take off. I also get questions around whether the system vendors or the routers and switches will put a block or lock into the open ZR Plus optics and also the OIF-based 400 ZR optics. And the question there is that, the answer there is, it remains to be seen. So far, we've tested it over a couple of different, or probably 4 different switch and router vendors, and so far we've always been able to get it to work. In some cases, we need to do some tricks to get it to work. For example, in one of the use cases, the switch did not support the setting of the wavelength. So all of those optics are tunable, but the switch did not support that. So what we did then was that we updated the firmware on the modules themselves, so we can preset the wavelengths and make that kind of sticky. So next time we set the wavelengths in an external box. When you plug it back into the switch and router, it remains with that wavelength. So then you have to pre-tune it before you plug it in. Once that switch or router vendor will add support for it, that will not be necessary anymore. But right now, that's where we are today. So we may or may not need to do any a small manipulation in order to get it to work. So that's pretty much where we are. If we look at the optical performance of those optics then, there are many passive networks out in the field today. And will the 400 ZR work over those passive networks? Well, typically the low channel count networks are built with thin film filters. They have a clear passband of about 30 gigahertz and a 3 dB passband of slightly below 60 gigahertz according to specification. And the typical bandwidth of the 400 ZR signal is 63 gigahertz. That means they will not work straight away. So then the other option is to use an AWG filter technology where you have sufficient bandwidth. But if you look at the end-of-life worst case loss for a typical 40 channel MUX on the market, they have an end-of-life loss on about 12 dB. And of course, that creates a challenge since the optical budget, if you run it passive, is only 11 dB. You basically don't get out of the house. So in order to get your 400 ZR to work over passive filter infrastructure, you need to qualify or use new filters with higher bandwidth. If you would ask your supplier of passive MUXes today, I would almost guarantee that they already have qualified or are in the process to qualify a filter with higher bandwidth, but that doesn't help you with all your installed base. But for new greenfield build-outs, you will be able to use the 400 ZR due to the bandwidth over the lower channel count filters as well. If we look at the optical performance over open line system then, so this is a kind of a busy graph here, but the bottom lines there, showing 2 different wavelengths running over the fiber lengths that you see on the bottom axis. And that's the indication of the prefect Baer value. So when you run it all the way up to 100 kilometer, you have a prefect Baer that is very, very good, and you don't get any penalty at all. But after about 100 kilometer, we start to see a slight degradation. And after 120 kilometer, the prefect Baer is very quickly degrading. And the limit for the prefect Baer is the solid line that you see on top there. So after around 135, 140 kilometer, that's when you have your limitation from a prefect Baer point of view. If we look at the OSNR, we see a that's the top graph, and it corresponds to the rightmost axis there with OSNR. We have an OSNR of approximately 30 dB, so that's way above the limit, which is the dotted line, 26 dB, all the way up to about 100 kilometer. Then it starts to degrade. So this indicates that you can run the optics without any penalty up to about 100 kilometer. And in this case now, 100 kilometer is actually not a distance limitation. It's an OSNR limitation. So it's 22 dB of link loss. So the optical performance in a ROADM-based network here, then you have, depending on what kind of traffic format you're using, then you can go different lengths. So if we look at an OIF-based optics, you can actually run it at 3 ROADM hops based on the network that looks like below. And then, so that means you can run it from A to D in this case. And if you would go with a open ZR plus cable optics, you can run it 5 hops. That means you can run it any to any in a network like this. And if you would go down in the modulation format or traffic format or line rate, you can run it at significant distances. So those optics are very well suited for used in ROADM-based networks. That was, I think, my last slide on the part there. On the case study here, this is the last slide. We have today deployed a fairly large network where the operator, a European operator, builds those dedicated rings when they run 400 gig router to router in kind of a meshed format. Each ring consists of 6 to 8 nodes. Totally, they have 8 rings deployed. They went with the 400 gig technology because of the cost and so on performances there. And it's an interesting customer because they use it in many different application modes. They use it on passive networks. They use it with an open line system. And last but not least, they use it with fiber or the optics connected directly with dark fiber. And of course, this will provide them with a cost-efficient solution with low power and low footprint. So we can skip the last slide there, Keith. So that was the session that we were intending to go through. So thank you from our side.
Thank you, Kent. Thanks, Keith. Well, we're running out of time, but let's take one question from the audience. Wilson Tan, does the 400G optic coherent optics draw the same power as a normal 400G gray optics? Will it cause the router to dysfunction because of the higher power requirement from the coherent optics?
That's a very good question. So it has a higher power class. So you have to make sure that the router support that power class. The OIF-based standard has a lower power draw and a lower power class than the OpenZR+. So it depends a little bit what optics you're using, but in many cases you will have a limitation, or let's say that you can only use the 400ZR optics on every 4th port or so. So it's very common that you have some kind of limitations on where and how you can use it. But you should be able to get the specification from your switch and router supplier.
Okay, thank you.